Okay, let us begin with the topic, which is something called as buoyancy and flotation. To begin, this is very important area in respect to fluid mechanics subject. So, to understand what the buoyancy is, what are the buoyancy forces, what are the flotation, what are the principle of flotation, and what are the Archimedes principle, we must understand it by two cases. By taking first case, a partially submerged body or a floating body. So there is this body, let us consider this body having the base area is A, and it is this is the symbol which is used to represent the surface of the water. This is the free surface of the water, and this part up to the depth h, it is inside the water. Okay, so what is the pressure at this point? What is the pressure at the base of this body? According to the hydrostatic law, pressure in a vertical direction is directly proportional to the specific weight, or we can also represent pressure in terms of height, which is P equals to rho g h. So P is nothing but rho g into depth up to which the base is there. Okay, so this is the pressure which is at this point, at the base of this body. Here the pressure is this rho g h, and area is the at the bottom. So vertical force which is exerted by the fluid is rho g h into area. And what is this h into a? This height, this depth into area is nothing but the volume. This volume is what? When the body is floating inside on the surface, when it is floating, this part, it is displaced by the body. So this is nothing but h into a is nothing but the volume of the fluid displaced by the body. So it is represented by VFD. So we can write rho g into h into a is nothing but VFD. What is this rho g? Rho g is nothing but the, we can call this as a specific weight. We know that what is a specific weight? Specific weight is nothing but weight per unit volume. And what is this weight? Weight is nothing but m into g by volume. And what is this mass by volume? Mass by volume is nothing but density. So we can write specific weight is nothing but rho into g. So specific weight is rho into g. So specific weight, which is weight per unit volume, is nothing but rho into g, and rho into g into volume is nothing but the weight of the fluid. So this rho g into v is nothing but the weight of the fluid displaced by the body. So this rho g v is nothing but the weight of the fluid displaced by the body. So what is the conclusion here? The vertical force whenever the body is partially submerged or floating body, the net vertical force acting on the body is weight of fluid displaced by the body. Alright, so moving on to the next case, which is completely submerged body. Now let us consider the case number 2. This body is completely inside the surface of the water, and this is again the symbol which represents the free surface, and the top side of this body is, let us consider at distance x1 from the free surface, and the base is at x2 distance from the free surface. Alright, so what is the pressure at this top surface? Is nothing but again pressure represented by rho g into h. Here h is nothing but x1. So this is the pressure which is supposed to be acting at this point, and also we know that force is nothing but pressure into area. So pressure is what? Rho g x1 into area is A. So this is the force which is supposed to be acting at this top side of this, and what is the force at the bottom of this is F2, which is rho g x2 into A. This is x2, this is the pressure. Rho g x2 is the pressure into area is again the same. So what is the net vertical force? Which is obviously F2 minus F1, which is rho g x2a minus rho g x1a. Rho g is taken common. X2 minus x1 is nothing but x2 minus x1 is h. So area into height. This area of the base of the body and height is nothing but the volume of the fluid displaced by the body. It is completely submerged. It is this volume of the fluid displaced by the body is here is exactly the same as the volume of the body, but here it is not same, because the half of some part of the body is inside the water. The volume of fluid displaced is different here, but here the volume of fluid displaced is same as the volume of the body, right? In both the cases, what we are seeing here, the net vertical force is equals to the weight of fluid displaced by the body. Net vertical force is equals to the weight of fluid displaced by the body. So what the conclusion here is, whether the body is partially submerged or a floating body or a completely submerged body, in both the cases the net vertical force exerted by the fluid is equal to weight of fluid displaced by the body, and this is called as buoyancy force, and this principle is something called as Archimedes principle. So the net vertical force is something called as what? Buoyancy force, which is also equal to the weight of fluid displaced by the body. Alright, so this is the buoyancy force. So now the point is where this buoyancy force is acting in vertically upward direction. Buoyancy force is basically due to the pressure difference, right? So buoyancy force have to act at certain point, like weight of the body has to, let us consider if G is the center of gravity of this body. So weight of the body is supposed to be acting at point G, right? So at G point the weight of the body is supposed to be acting, which is acting in downward direction. Yes or no? Now what is the point where this buoyancy force is acting? If this is a floating, this weight of the body must be equal to the buoyancy force in order to keep this in a floating under equilibrium condition, right? So what is the buoyancy? What is the point where the buoyancy force is acting? It is something called as center of buoyancy. What is center of buoyancy? It is the point where the buoyancy force is supposed to be acting. The point where the buoyancy force is supposed to be acting, it is represented by symbol B. It also acts as center of gravity of displaced fluid volume. Now you can see over here, let us consider this body is again floating. G is the point where the weight is supposed to be acting, and B is point where the buoyancy force is supposed to be acting in vertically upward direction, right? So this buoyancy force act at center of buoyancy, right? And we also have mentioned over here, it is also act as center of gravity of displaced fluid volume. So center of gravity of displaced fluid volume, what does it mean? This G, let us consider this body has a height h. So G is at certain distance of h by 2. Similarly, B is what? Center of buoyancy. It acts as center of gravity of displaced fluid volume. So what is the displaced fluid volume? Let us consider this is inside the depth x. The body is inside up to the depth x, and B is the point. So center of buoyancy must be at x by 2 distance from the bottom. So B is the center of buoyancy where the buoyancy force is supposed to be acting. It also acts as the center of gravity of the displaced fluid volume. Now let us take what the principle of flotation is. What is the principle of flotation? The principle of flotation says that when a body is floating under the equilibrium condition, then what is the weight of body must be equals to the buoyancy force. What does it mean? So let us consider this body. It is floating under the equilibrium condition. What does it mean? G is the point where the weight of the body is supposed to be acting. Let us say this is W, and B is the point which is center of buoyancy where the buoyancy force is supposed to be acting in vertically upward direction. Let us say this is FB. For equilibrium condition, this buoyancy force must be equal to the weight of body. The weight of body is acting in downward direction. And buoyancy force is acting in upward direction. Okay. So this, for equilibrium condition, these two forces must be equal and the line of action of these two forces must be same. So weight of body is equal to the buoyancy force, and also we know that buoyancy force is what? Weight of fluid displaced. So which means weight of body is equals to weight of fluid displaced. So this is something called as principle of flotation. When the body is under the equilibrium condition, floating under the equilibrium condition, the weight of body, which is equal to buoyancy force, must be equal to the weight of fluid displaced. And it must be there, the line of action of these two forces must be same. So let us begin with what is the stability conditions of the completely submerged body as well as a partially submerged body, which is also called as floating body. So completely submerged body, what are the conditions of stability? And for the stability, for the sake, we must understand stability by the ball and the ball case. Let us consider there is this ball which is keep inside the bowl. It is the most stable condition of this ball. So it is a stable condition. This is the most stable condition of this ball. So what happens if we reverse the condition and putting the ball on the other side of this bowl? So this is the most unstable condition of this ball. So this is how the stability can be explained in a very simple way. So it is a more unstable condition of this ball. It can be it has a free to move anywhere, but in the reverse case, whether has to move over here, it is most stable condition is here only. So it is most simple way to understand stability what is. So let us consider there is a first case, completely submerged body. So there is this body, the n is nothing but something called as neutral axis of this body. So what we are doing here is we are taking the two cases. In the first case, the center of buoyancy of this body is above the center of gravity, and this is the center of gravity of this body, and this is the center of buoyancy of this body. In the second case, what we are doing is we are taking center of gravity of this body is at the top side of this, and above the center of buoyancy, and this is the center of buoyancy. Here center of buoyancy is above the center of gravity. Here the center of gravity is above the center of buoyancy. There are two possible cases might be there in the case of this body. So if let us consider first case, if the center of buoyancy of this body is above the center of gravity, what happens in this case? If we are giving the moment to this body, let us consider if we are giving the moment to this body in an anti-clockwise direction, what happens? The line of action, which is in the case of neutral equilibrium, is same. The weight of body is acting in downward direction and the buoyancy force is acting in a vertically upward direction. These two of the forces are balancing each other and it will create a neutral equilibrium condition. Now what is we are doing? We are giving the angular twist to this body. In this case, if the center of buoyancy of this body is above center of gravity, this is the point where buoyancy force is acting and G is the point where the weight of the body is supposed to be acting. So weight acting in downward direction, buoyancy force is acting in upward direction, but you can see over here the line of action of these two forces are different. So weight is acting in downward direction, buoyancy force is acting in upward direction. So as we are giving the moment to this body, the restoring couple is supposed to be generated because the buoyancy force is acting in upward direction and weight is acting in downward direction, and this creates a restoring couple. If we are giving that anti-clockwise moment to this body, couple to this body, and again the body comes back to its natural position. So it is again because of the couple generated with the B and G, buoyancy force and the weight of the body. So it will again back to the same position. So it is a stable condition. It is a most stable equilibrium condition. Now what happens in the other case? If the center of gravity lies above the center of buoyancy, if center of buoyancy is below the center of gravity, what happens in this case? If we are giving the moment to this body, again the same case, if we are giving the moment to this body, what happens? The buoyancy point, the center of buoyancy force is acting. At the center of gravity, the weight of the body is supposed to be acting. And as we are giving the moment to this body, again the buoyancy force, the line of action of these two forces are different. So buoyancy force, this force is acting in upward direction and weight of body is acting in downward direction. There is the distance between these two line of action of forces. So this creates a couple. So again the couple is in the same direction as we have given the disturbing couple. So it will we can say it is an unstable condition because the couple we are giving, it is again moving in the same direction and it is supposed to be drawn like that. So it shows how the unstable condition of this body. So in the case of completely submerged body, the three possible cases are there. When the center of buoyancy is above the center of gravity, it is stable equilibrium. So restoring couple. So we are giving the couple in anti-clockwise direction. Again we are giving the couple. It is supposed to be happen couple in clockwise direction. So restoring couple is supposed. Disturbing couple is equals to the restoring couple here. So it is a stable condition. So when B is above G, it is a stable equilibrium. When B lies below G, it is unstable equilibrium, and when B and G coincides, it is neutral equilibrium. This is the case of completely submerged body. Now moving to the second case, partially submerged body, or we can say floating body. So in that case, we can see over here that this body is floating, right? And this point is center of gravity, where the weight of the body is supposed to be acting W, and G is the point center of gravity. Yahan, this point, the weight of body is acting in downward direction, and B is what? Center of buoyancy. It is the point where the buoyancy force is supposed to be acting. So buoyancy force acts in vertically upward direction. So the line of action of these two forces are same. So it is under the neutral equilibrium condition, right? So it is a neutral equilibrium condition in this case. Now what happens if we are giving the disturbing couple to this body, if we giving the moment to this body, what happens in this case? As we are giving the moment to this body, the center of gravity remains unchanged in both the cases. There are two possible cases are there. When center of buoyancy, when we are giving the moment to this body, this center of buoyancy has changed its position from B to B1, because obviously the fluid displaced is supposed to be changed over here. And in that case, let us consider the first case. If the buoyancy force, center of buoyancy changed from B to B1 here. Now in that case, now the new buoyancy force is supposed to be acting at from the B1 point, right? So this acting in vertically upward direction, and G is the point where the weight of the body is acting in downward direction. So at this point, when the buoyancy force is acting in upward direction, the line of action of these two forces, where it intersect the normal axis of the body. This is the normal axis of the body, N is normal axis of the body. The intersection of normal axis of the body and line of action, new line of action of the buoyancy force, this is something called as M, which is something called as metacenter. This is metacenter. Well in that case, what is happening over here? Buoyancy force is acting in upward direction here, and weight is acting in downward direction. The line of action of these two forces are different, and as we are giving the disturbing couple in clockwise direction, we are supposed to be happen that the restoring couple we are supposed to be getting by the buoyancy force and the weight of the body. So it is in anti-clockwise direction. It again come back to its same position where it is disturbed. So it is the stable equilibrium. So what does it mean? When M, which is metacenter, metacenter is the point where the body tends to oscillate. It is the point where the body is supposed to oscillate. It is also defined as intersection of normal axis of the body to the new line of action of the buoyancy force. You can see over here, normal axis of the body to new line of action of buoyancy force. This is something called as metacenter. Now when metacenter above the center of gravity, when the metacenter lies above the center of gravity, it is the condition of stable equilibrium. You can see over here, when metacenter above the center of gravity, it is the condition of stable equilibrium. Now in the second case, now see again what happens. Again we are giving the disturbing couple to this body, but in that case B again has G doesn't change its position because G remains same, but B changes from B to B1. Now in that case, again new line of action of buoyancy force is this, and B1 is the new center of buoyancy where the buoyancy force is supposed to be acting. Now metacenter here is again the point of intersection of normal axis of the body to the new line of action of the buoyancy force. This point is metacenter. Now in this case, metacenter lies below the center of gravity. Metacenter lies below the center of gravity. Well in that case, if you can see over here, buoyancy force acts in upward direction here, and weight of the body acting in downward direction. So the line of action of these two forces are different. Now it creates a couple in clockwise direction. We are giving the disturbing couple in clockwise direction, and we are supposed to be happen again the couple in clockwise direction. So it is the unstable condition. It will not it will not go back to its position where it is disturbed. So it is an instability. So when metacenter is below the center of gravity, it is unstable equilibrium. When metacenter above center of gravity, it is stable equilibrium. and when M and G coincides, it is neutral equilibrium. That is condition when the line of action of these two forces are same. So these are the condition of stability of completely submerged body and as well as partially submerged body. Now you can see over here what is G. G is the center of gravity. M is what? Metacenter. And the distance between G and M, this is something called as metacentric height. Metacentric height. So when metacentric height GM, when metacentric height GM is positive, when metacentric height GM is positive, it is stable equilibrium. When GM above lies above, this is positive. When metacenter lies below the center of gravity, this is what? Negative. Means when GM, the value of GM is negative, it is unstable equilibrium. When this is 0, it is neutral equilibrium. So GM is metacentric height. When it is positive, it is stable equilibrium. When it is negative, it is unstable equilibrium. When it is 0, it is neutral equilibrium. So that's how we can justify the stability condition of floating as well as submerged body.